that on after one beer. We'll have to do that.
Well, I think I already pressed start. So
okay, whoops.
welcome to Grumpy Science. I hope I wasn't picking my nose or anything. This is Mark Tommerdahl and Bob Dennis.
And to start off, I'd like to say somehow, we really appreciate the 4 or 5 fans that we have who have been hitting the view button and getting our numbers up.
And that includes the 2 of us.
Yeah. And actually, one of them even sent me a hat. So I have to, that says Grumpy, if you can see it now. I have to say thank you. That was really, really flattered. It's sort of like maybe we should start doing car talk and say, send your puzzler in, your answer to the puzzler in on, Bob didn't get a hat because apparently he's not as grumpy as I am.
Well, we're going to have a Who's Grumpier contest here, and you can write us an email and vote for who you think is the grumpiest. I'm not going to say what I think, but, we'd like to hear what you think. So there it is. Anyway, so today, what are we going to talk about, Mark?
Well, let's start off answer another question so we don't get too far behind. We just getting floods of emails from our fan base.
Our enormous fan base, both of you.
3.
Right, all 3
of you. So, basically, I'm wondering if you can compare brain gauge to memory performance test games, for example, dual them back as a measure of brain health. Some factors you can compare them on are what kinds of brain problems, et cetera, et cetera. Okay, so first of all, what we do with the brain gauge is these are measures of information processing. And what that means is we are looking at the basic components of what things like learning and memory are dependent on. So you always hear about learning and memory, but plasticity is a big component of that. So is lateral inhibition. We've talked about that. Somewhere in one of my lectures. But anyway, lateral inhibition is one of the tests we do, and plasticity another test. But those both feed into the whole learning and memory process. Okay, what kinds of brain problems is the test good at detecting? Basically, any brain problem that alters brain health. So any deviation from brain health is something. Now you have to remember, we don't want to go down this path of saying that the brain gauge can differentiate 2 completely different neurological disorders, like say autism and concussion. So if you're trying to decide whether you have autism or concussion, or if you're an alcoholic, you should think a little bit about the medical history. Are you drinking a lot? And did you bang your head on the wall? Or do you have a neurodevelopmental disorder? Those are very different things. But people actually do ask that question. Can you determine the difference between, say, one neurological disorder like autism versus somebody who has a concussion? The answer is sometimes people with concussion look a little bit like some people with autism. The problem is, or the difference is, that the people with concussion recover. And you can track that recovery. Test, retest, stability, variability, repeatability about the brain gauge. Well, we've got, I think, 7 different papers, working on a few more, but where those things are addressed. And the way we did that in those papers is we actually gave, in one case, we gave a drug to some people and a placebo to another. So that's called a double-blind placebo. Nobody knows who has what. And people took tests continuously over a course of 45 minutes to actually about 6 hours. And the people who did not take the placebo, or the people who took the placebo and did not take the drug, their testing stayed the same. The people who took the drug, their test scores got worse and then got better. So depending on which direction you want to say is good versus bad.
Yeah.
How many data dimensions the test returns versus how long to take the test. Each test takes roughly between 90 seconds, 2.5 to 3 minutes, somewhere in there. Each time you take a test, it adds at least 1 dimension. If you take paired groups of tests that are paired logically together, that adds 3 dimensions. And so what you mean by dimension is your CNS profile or your brain health profile is actually in multi-dimensional space, and so each measure means something different. And so when you combine those measures, you start to get a profile of the different dimensionality. And that's how you start to get a feel for how well you are. Tests cause fatigue / annoyance / grumpiness. Well, this is a great question. Now let's start with the last question first.
I think the grumpier you are, the better you do. In my opinion, I tend to get 100 on everything, but that's just me.
This sort of depends on your generation. So,
and your tolerance for grumpiness.
So we've done tests across all age spectrums, and we give the test to college age students all the way up through people 80 and 90 years old, and the people who are in what we call the greatest generation, no matter how hard the test is, they don't get a bit grumpy. They say, "Oh, yeah, sit down and take it, no problem. 20 minutes, I can do that." And you try to take someone else off their video game for 10 minutes.
Like me, for example,
Yeah.
where I grab a toaster, come on, toast, kind of thing.
And they can get really grumpy because I don't want to take 10 minutes to take a test. It's like, oh, okay, well, that's really up to you. But as far as fatigue, it's really up an individual thing. Some people really don't have a problem spending 10, 15, 20 minutes testing themselves. The fastest test you can do is simple reaction time. That takes 90 seconds. If that's all you do, that's all you do. That's fine.
We have a super user who uses this secretly. It's my wife. She uses it a lot, and I didn't think she would like it at all. And I asked her why she likes it so much. She uses it 3 or 4 times a day, and she says she's just very interested in seeing what the results are and how her different states of fatigue or what she's eaten or whatever has to do with her brain function. And I think it's a lot like a lot of other things in life, right? I mean, if you take an interest in it and you put effort into it, it'll give you a good result. And if you don't take much interest in it and you don't put much into it, it doesn't give you much back. So, that's I think there's some truth to that with the brain gauge. If you have a serious interest in knowing what's going on with your brain health, you're likely to get good answers. If you're kind of taking the test and sort of watching an iPad and thinking about other things, I think it's not as good.
Yeah. Well, another thing, test cause fatigue. Well, actually, we test for fatigue. And so when we're testing student athletes, for example, who are testing to see if they recover from concussion, we do a battery of tests that takes, again, 15, 20 minutes. And what we do with the last test is compare it with the results of the first test. And that is actually the fatigue measure. So what we do is see how far off they get on each successive test. If they're getting worse and worse and worse on the last test, then they're fatigued. And basically what the last thing people recover from is where they've taken the test for 15 minutes. All their scores look good except for their very last one, which is that test is identical to the first one. And sometimes scores go up 30, 40, 50% because they got tired doing 15 minutes of testing. Now, if a 18 to 22-year-old student athlete is getting tired doing 15 minutes of what's essentially a video game, then they probably shouldn't they're not recovered.
Yeah.
And let me go back to our test, retestability, validity, and all that stuff. So we've done a lot of testing in a lot of different venues. But the one way that we do validation studies, and I mentioned that we do some drug studies with a double-blind placebo, but we also do things called studies with TMS, which is transcranial magnetic stimulation, TVCS, direct current stimulation. And in each of those, where people are tested throughout the entire session for 90 minutes to 4 hours, where they keep taking the test and they're either given a blast of TMS or they're giving a sham TMS that sounds to them just like they're getting it. And we see big changes with those interventions, but no changes with the sham protocol. Anyway, but those validations, but we use different methods for doing correlative studies where we do MRI or fMRI or MEG or MRS, different kinds of imaging along with the brain gauge, and compare brain gauge measures to imaging measures. Anyway, I think our time is about up. The last thing to mention is that we're hiding a discount code on my hat. So if you can read that word that's on my hat, that is a discount code good for 20% off any brain gauge products.
There you go. So that was a little bit of a product ad, but
we're
that's
doing product placement, but
that's okay. So, and the other thing I wanted to say is, it's interesting to know that the brain gauge can detect some of these electromagnetic effects on the brain, that TMS, which is transcranial magnetic stimulation of the brain. I'm sure we'll have plenty more to discuss about that kind of thing in the future, but for now,
great question.
Thanks a lot.
Next time you email a question, let us know if you want us to, if it's okay to read your name on the air.
Maybe your name and an initial or something like that. All right, thanks a lot. Bye.
See ya.